Among the LPWA communication standards used in the construction of remote IoT systems, LTE Cat M1, using the lightweight and power-saving Mqtt protocol, enables the construction of IoT systems that cover large areas using cellular network infrastructure. Here, let me introduce a solution for LTE Cat M1 Mqtt communication using Renesas RL78 microcontroller, which offers the industry's lowest power. This solution uses the RL78 G22 as the host microcontroller to realize applications using the Mqtt protocol supported by the LTE Cat M1 communication function of the LTE module RYZ024A. The RL78 G22 LTE Mqtt communication application note can be tried on the RL78 G22 Fast Prototyping Board and PMOD Expansion Board for RYZ024A. Next, explain hardware setup, software setup, and operation. Let me explain about hardware setup. The PMOD Expansion Board for RYZ024A comes with an external antenna and an MVNO SIM card. Insert the activated SIM card into the microSIM connector on the back of the PMOD. Then connect the antenna to the SMA connector and USB power to the USB connector. Connect the PMOD Expansion Board for RYZ024A to the RL78 G22 Fast Prototyping Board and connect the RL78 G22 Fast Prototyping Board to a PC with a USB cable. Next, prepare the software. Here is an example using E² Studio. Download the sample program from the RL78G22 LTE Mqtt communication application note and import the sample project into the integrated development environment. Specify the access point name, authentication protocol, username, password, and LTE band used to connect to the LTE network in LTE entry.c as string data. The data to be set for the access point name, authentication protocol, username, and password vary depending on the SIM card used and should be changed according to the application. Please contact the SIM card provider for the names of the access points that can be used. Username and password may be abbreviated. LTE bands vary depending on the region and operator used. If you know the LTE band to be used, please specify that band. If the LTE band to be used is unknown, configure as shown in this example. Once the configuration is complete, build the project. Write the download file to the board using Renesas Flash Programmer. By using the terminal software, specify the COM port of the RL78G22 Fast Prototyping Board and connect it. After executing the sample program, you can check the results of sending and receiving messages with terminal software. The sample program uses a public Mqtt server as an Mqtt broker to send and receive messages. When the sample program is executed, the RL78G22 resets the RYZ024A module, and the RYZ024A connects to the network via LTE, then to the Mqtt server. After that, a subscribe request is executed to the Mqtt server. In this state, it is possible to confirm the sending and receiving of messages using the switches on the board. When the switch on the board is pressed, the message is sent to the Mqtt server by publish. When the Mqtt server receives the publish, it sends the message ID and other information to the RL78G22, which is the subscriber. The RL78G22 sends a request to receive the message and displays the received message on the console. The string data to be sent will be changed depending on the number of times the switch is pressed. Also, by simply changing SSTR Mqtt username in LTE entry.c of the sample program to a value other than the default, it is possible to realize remote communication between two boards via an Mqtt server. Thus, the RL78 LTE Mqtt Communication Application Note contributes to the easy construction of remote notification systems and monitoring systems that notify the human detection, using cellular network infrastructure even without a nearby network environment. For details, please download the RL78 LTE Mqtt Communication Application Note from the Renesas website.